Friends, welcome to Makey Techie. Learn as engineer and teach as champion. First of all, I would like to thank my family for their continuous support and encouragement to create these kind of technical videos in public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore. And I would like to thank Almighty for my good health and my friends and followers and my students and subscribers for their continuous support. And today's topic of interest is introduction of theory of machines. Generally, theory of machines is an important subject in a mechanical engineer for a mechanical engineer because it defines the static as well as the dynamic bodies in motion as well as in rest. First of all, today we are going to discuss the theory of machines basics. So, here we want to understand that what are the type of a bodies. First of all, the bodies are in two different types. One is a static body and another one is a dynamic body. Static body, a body under rest is called as a static body, and dynamic body, it is body under motion. Here in dynamics, we can subdivide into two types. One is kinematics and another one is kinetics. Here, kinematics deals with the effect of force on a rigid body under motion without consideration of external force. Whereas in kinetics, it deals with the effect of force on a rigid body under the motion with consideration of force. So here we have to understand that the kinetics means considering external force. Kinematics means without considering external force. Here we are going to discuss about kinematics of machineries. Here we know that a machine should have a relative motion by the sum of the machine parts. Here the kinematics means we should not consider any force on the machine member. Therefore, it can be defined as the relative motion of a machine part without considering the applied force. That is called as kinematics of machineries. Okay, so what are all the things in the kinematics means? We have a displacement, velocity, acceleration, and jerks are applied in the kinematics of machineries. Next, an important thing, it is link. What is meant by a link? We can call it as an element. Elements are connected together to perform a relative motion. For an example, this is a link. So here it is a connecting rod. For an example, this is a crankshaft. So crankshaft, and this is a connecting rod, and here is the piston. A link which will connect the piston and the crankshaft, that is called as a connecting rod. It is simply called as a link between the piston and the crankshaft. So I hope that you have understand what is meant by a link. And next one is the kinematic pair. The kinematic pair, it is a very important and interesting thing. Two links are connected together to perform a relative motion. When the two links, the previous one, the piston, connecting rod and the crankshaft, each are different types of elements. So how we are connecting? How we are connecting these two links? For an example, if the piston is connected with the corn rod by means of a gudgeon pin, so gudgeon pin will be act as a kinematic pair. Okay, so the different types of pairs will come in the next content. So first of all, you have to understand the what is meant by kinematic pair. So two links are connected together to perform relative motion. Next one is the kinematic chain. More than two links are connected together to perform a relative motion, which is called as a kinematic chain. Kinematic chain, okay. Next, the binary join. What is meant by a binary join is that two links are connected together. If you consider this is a link, sorry, so this is a one link, this is a link 2. So link 2 and link 1 both are coupled by means of a join. Okay, this is called as a binary join. So two links are connected by the means of a join, which is called as a binary join, where the ternary join is like this, a triangle thing. So three links are connected by means of two binary join, which is called as a ternary link. Okay, and next one is the quaternary link. Quaternary link are four links are connected by means of three binary joins. So we know that one binary join having two links. Therefore, four links are connected by means of the joins, which is called as quaternary join. Quaternary join having three binary join and ternary join having two binary join. Okay, please make a note this. Next one, what is meant by a join? Join, a point at which links are connected together, that is called as a joins. A point, or we can simply say it as a point which connects two elements, which is called as a joins, or sometimes we call it as a nodes. In finite element analysis, we call it as a nodes. Two elements are connected by means of a nodes. Here two machine elements are connected by means of a joint. Next one is a mechanism. What is meant by a mechanism? So we know that all our mechanical components are merged with the mechanisms. The mechanism is one of the link is fixed in the kinematic chain and other links having some relative motion. This is called as a mechanism. For your better understanding, let's consider this is a kinematic chain. This is a parallelogram kinematic chain. Here, if we are constraining the bottom chain, means what will happen? There is a relative motion here, and there is a relative motion here, and this link having a linear motion of this side. So since in the 4-bar chain, one bar or a one link is fixed and the other links having a relative motion, so this is called as one type of a mechanism, where like this the different links are fixed to obtain different mechanism, that is called as an inversion. So you have to know the difference between the mechanism as well as the inversions. So inversions are fixing different links and different mechanisms are obtained, that is called as inversions, where the mechanism is the fixing of one link in a kinematic chain to obtain some relative motion. Okay, so this is the clarity you need to know about the mechanism as well as the inversion. For your better understanding, I would like to quote an example. In previous, we have a 4-bar mechanism, 4-bar parallelogram mechanism. If in the 4-bar kinematic chain, how many number of inversions means the number of inversions is equal to number of links in the mechanism. If you see here, we have a 1, 2, 3 and 4. 4 links are available, therefore number of inversions is 4. For an example, you can fix this one first and you can obtain one type of mechanism, and you can fix this one and obtain 1 3 4 as some mechanism. By fixing the link 3, you can get 4 1 2 as a different kind of mechanism, and fixing 4 1 to 3 is formed as a different type of mechanism. That types of inversions and types of mechanisms we join across the forthcoming slides. So with this information I would like to make the introduction is very interesting, and the type of pairs, next we are going to discuss about the type of pairs. It is very interesting and important thing. First of all, we have to know what is meant by lower pair and what is meant by higher pair. In lower pair, if the contact area is more, we say a contact area surface having a contact, which is called as a lower pair. In surface contact, the area is become huge and the coefficient of friction becomes more. Therefore, the pair is having a lower pair. For an example, the rectangular hole in and a shaft, it is a lower pair. All point in the slider crank mechanism as well as the flat belt are all lower pairs. These are all the examples of the lower pairs, where the higher pair is like a point or a line contact. Only a single point is in contact, that is called as a higher pair. We need to concentrate on more in higher pair. More accurate motions are to be done in the higher pairs. Like that, cam and follower, ball and roller bearings, V belts and pulleys are all having higher pair. So their accuracy and the motion is very precise. So here I hope you have understand what is meant by a lower pair and what is meant by a higher pair. Next one, it is another pair type of a pair. It is self-closed pair and forced closed pair. Here, two links are connected together without without any external force are able to perform kinematic motion, that is called as a self-closed pair. For your better example, all turning pairs are self-closed pairs. Next, forced closed pair. Two links are connected together with any external force are able to perform kinematic motion, that is called as a forced closed pair. This is for your better understanding. Our engine cam and followers are the forced closed pair, where valves are coupled by means of a concentric springs. It will store the energy and it will retain the energy for the valve operation. Valve is connected with the cam and follower. Simple. The valve is connected with cam and follower. Therefore, the spring is used to make the cam and follower as a forced closed pair. Next one is a different types of a pair for the simple understanding. Turning pairs or the circular shaft in the bearing is a turning pair. Sliding pair, rectangular rod in a rectangular hole is a sliding pair. Piston cylinder arrangement in the IC engine is a sliding pair. Screw pairs are lead screw and nut. Lead screw and nut in the lathe machines are the screw pairs, or a screw jack is a made up of a screw pair. Rolling pair, road rollers in the road, and cylindrical bearings are the rolling pairs. Cylindrical bearings, needle bearings, taper bearings, all are a rolling pair. Next, spherical pair, ball bearings, ball joints in the front axle of our four-wheeler vehicles, and ball and socket joint, joystick in the phones, joystick in the mouses, and pen stand are all spherical pairs. Next, a very important thing, different types of motion. One is completely constrained motion. What is meant by completely constrained? The motion is desired direction or definite motion. It is called as a completely constrained. If I want to make my mechanism to deliver these kind of force, for an example, this is my piston cylinder arrangement and control arrangement. The piston should move in this way. For that only the cylinder is mounted. So this is a completely constrained motion. And also we are having a rectangular hole and we are having a rectangular shaft. That is a completely constrained motion, or we can say a bearing with a circular shaft, and the end we have a collars, and both the ends we have a collars. So this arrangement, this assembly will should rotate, which only rotate. So these are all a completely constrained motion. The motion is desired motion in desired direction, or definite motion is a called as completely constrained motion. For this, sliding pair, turning pair, rectangular hole in rectangular slot, rectangular hole in with rectangular rod, shaft with bearing with the collars are all completely constrained motion. Where incompletely constrained motion, for desired input there is no definite motion, that is called as a incomplete constrained motion. For your better understanding, I quote a previous example. Here it is a bearing, here it is a shaft. Okay, when we are trying to rotate, if there is some axial thrust, what will happen? The shaft will tend to slide on the bearing. We are giving only rotation by means of a uh, axial thrust. Due to the motion, it can slide also. So this is not defined motion, where rotation is a definite motion, where sliding is not a definite motion. That is why it is called as incompletely constrained motion. Next one is the successfully constrained motion. There is no definite motion in the output, but via some external force is applied to get desired motion. For this, a better example is a footstep bearing. Footstep bearing is a better example, as well as piston cylinder arrangement with the piston pin. We have a piston cylinder arrangement. So this you can understand very much. If we have a piston cylinder arrangement and the connecting rod is coupled by means of a pin, so here the definite motion is there by means of a piston. For the in terms of jaddering as well as the turning motion, the piston pin is coupled. So it is forced the piston to move only in linear motion. Whereas this type of lateral motion is also possible, but the piston and rings will not allow the piston to move in the transverse direction. So this is called as a successfully constrained motion. I hope that the different types of pairs and different types of motions are very much interesting, and that you have a better knowledge on this. And I would like to move on the degree of freedom and degree of constraint. The degree of freedom and degree of constraint are just opposite signs. The degree of freedom is the number of independent input link required to give a desired output motion is called as a degree of freedom. If you are having a shaft in a space, what are the possible motions here is the shaft can move in the x direction, the shaft can move in the y direction, the shaft can move in the z direction. Therefore, three linear, as well as the shaft can rotate in clockwise x, clockwise y, clockwise z. Therefore, which is having three rotary motion. Therefore, totally we have a 6 degree of freedom for a shaft in a space. In some of the books, they can say it as a 12 degree of freedom, 12 degree of freedom, that is by means of a positive linear motions, positive linear axis, as well as positive and negative linear axis, and as well as clockwise and anti-clockwise rotational motion are considered. Therefore, the shaft in the space will have a 12 degree of freedom. So whatever may be, generally most of the books are having 12 linear and 12 sorry, 3 linear and 3 rotary. Therefore, all the link in a space having only 6 degree of freedom. So therefore, we can consider that one as a right. And what is meant by a degree of constraint? We now only we see that the degree of number of degree of freedom in the space is 6 minus degree of freedom is equal to degree of constraint. How many constraints are required for the for make our link to free in certain direction or certain motion? So that is called as a degree of constraint. Now we are going to discuss some of the degree of standard results of some of the degree of freedom of different shapes. First one, for the sphere, that is, spheres are generally used in ball and socket joints, joysticks, etc. And also ball bearings, we can see. The balls, spherical balls, are having 3 degree of freedom, and cylinder is having 2 degree of freedom, and all other like bolt and nut, prismatic pair, etc. are having 1 degree of freedom. For the space, anything in the space having 6 degree of freedom, and the planar motion will have a 2 turning and 1 rotational as a 3 degree of freedom in the planar motion. You can get a questions like this: how many degree of freedom having a planar mechanism means it is having 3 degree of freedom, whereas in the space coordinates it is having 6 degree of freedom. Like that, you can get a question. So if you remember these things, you can easily understand and you can write the values. Okay, next, in the degree of, if we discuss the degree of freedom, we definitely cross the two different types of uh, equations. One is Kurzbach equation, and the one is Krupler equation. Here, they are considering four different parameters like J as a lower pair, N as a number of pairs, and H is the number of higher pair, and n we can call it as a number of binary joint or number of links. Therefore, the Kurzbach equation will relates the degree of freedom f is equal to 3 into n minus 1 minus 2j minus h. Therefore, here the h is the higher pair and j is the lower pair. So Kurzbach will consider both the higher pair and lower pairs available in the link. Next one is a Grubler criterion. Grubler criterion will not consider the higher pair. So this is the difference between Kurzbach and Grubler criterion. So Grubler criterion is the 2j minus 3n plus 4. So this is the equation for the Grubler criterion. So we can easily remember Grubler means 2, 3, 4. So 2, 3, 4. One positive, one minus, one positive, and another one is a 0. Okay, like that we can easily understand. Next, an important thing, an important formula, instantaneous center. The instantaneous centers are the point where the motion is to be done. So the number of instantaneous centers are having a formula n into n minus 1 divided by 2. Okay. Next, we are going to deal with some of the theorems which are available in theory of machines. And the first one is a D'Alembert's principle. D'Alembert's principle. The dynamic problem is solved as assumed to be a static problem. So this may be in your 2 more questions in your probably in your subject, or we can take it as a 1 more question. So as per the D'Alembert's principle, dash problem is considered to be is solved by assumed it as a dash problem. Like that they can ask, you can remember by the name itself, D Alamberts. So first letter start with the D and last letter start with the S. Therefore, the dynamic problem is solved as it is assumed to be a static problem. Like that, you can assume. Next one, it is a Kennedy theorem. Kennedy theorem. It is very very important. If you can remember this theorem by means of a story. So Kennedy loves ice cream. So Kennedy loves ice cream. So what it is? If we know that I stands for instantaneous. So instantaneous center. So here I would like to explain three things. One is I denotes instantaneous center, and in the I, capital I, we are having three links. 1, 2, 3. Okay. So three bodies, we can say it as a three bodies. Okay, when three bodies are relative motion, three bodies are in relative motion, the instantaneous point lies in the straight line. So by means of this, you can, by means of an I, you can easily remember the Kennedy theorem. So I can repeat, Kennedy loves ice cream. Therefore, I relates instantaneous point. So instantaneous point of where, again you look the I is having three bodies, three straight lines. Therefore, if the three body is in relative motion, the instantaneous point lies in the straight line. Like that you can easily understand. Grubler rule, it is only for the planar mechanism, and one planar mechanism only lower pair is considered. And next one, Klint's construction. Klint's construction, very very interesting phenomena. Klint's construction, the acceleration is constant and uniform angular velocity into acceleration is equal to constant. Next, Geneva mechanism. Geneva mechanism is used in the turret lathe for making different types of tools in different position. The turret mechanism is used. In the turret mechanism, Geneva gear mechanism is used. What the Geneva mechanism will do means, the continuous input will deliver as an intermittent output, intermittent motion in the output. That is the function of Geneva mechanism. Next one is a Scotch yoke mechanism. Scotch yoke mechanism is a simple harmonic motion and it will generate sine functions. So these two things you have to remember. So Scotch yoke mechanism will give the simple harmonic motion and it generate sine function. For this Scotch yoke mechanism, for your better understanding, I hope that we are all mechanical engineers. There is no things to making understanding wrong. We know that scotch. What happens if we drink scotch? If we drink a scotch, it will give a internal harmony. Therefore, by means this thing, we can understand that Scotch yoke mechanism will give a harmonic, that is simply harmonic. What will happen if we drink a scotch? It will make us simply harmony. Therefore, Scotch yoke mechanism, simple harmonic motion. So like that simple. And next one, without quick return mechanism, it is in the quick return without quick return mechanism. Name itself, we have a thing. It is for the quick return motion, and where without quick return mechanisms are used in slaughter and shaping machines. Next one, and another kinds of a mechanism, double slider crank mechanism. In double slider crank mechanism, we have three inversions. We have three inversions. One is Wolfram's coupling, next one is Scotch-Yoke mechanism, next one is an elliptical tormal. And this thing can be understand by means of a song, a Tamil song from the film Osti. So that film name itself, Osti, from the film name itself, we can understand what is meant by a double slider crank mechanism inversions. Here, the O indicates Oldham's coupling, S indicates Scotch-Yoke mechanism, and the last letter T indicates the elliptical tormal. So we can understand by means of a line, by means of a film name, or by means of a song, we can understand the double slider crank inversions. Next one is a universal coupling. So here the universal coupling is used to connect intersecting shafts. It is also called as a hook joint. Angular power transmission are possible. Next one is a plantograph. Plantograph is a very important and interesting mechanism. It is a copying mechanism. So we all know that in the drawings we drew the drawing in either an actual scale or reducing scale or an enlarging scale. What will happen? The complete replica of the drawing is there, where the size of the drawing is smaller or enlarger or as a standard dimension. Like that we are making a copies. So here the plantograph is a one type of a copying mechanism. It is used in machine tools. We all know that copying machines on some special purpose lathes are there. Copying lathe form tools are used to make a copying shape of the tool shape the component will do. So like that the mechanism is called as a plantograph mechanism. Even our copying machines are of the form of plantograph. Next is a exact straight line motion, and for the slight misalignments, Oldham's coupling as well as Bushed couplings are used. For the exact straight line mechanism, there are three mechanisms to provide very exact straight line motion. That a Hart mechanism, Poncelet mechanism, and Scott-Russell mechanism. Here we can understand by means of two things. One is hydraulics and pneumatic systems are the interesting subject in the mechanical engineering branch. Therefore, H indicate Hart, P indicate Poncelet, and S indicate Scotch-Russell. Or we can say by means of the names we are having hot. We are having hot. What happen if the heart is pumping the blood in an irregular manner? We won't work. We realize that. Therefore, heart should be worked as exactly. Therefore, heart mechanism is an exact straight line mechanism. And another one is a famous West Indian bowler, Scott Russell. Scott Russell is there. He bowled the ball in exact straight line. Therefore, he batting his bowling is very difficult for the batsman because he bowled the ball in exact straight line. Therefore, by means of his name, we can understand the Scott Russell mechanism is an exact straight line mechanism. Next one, indicate inexact straight line mechanism. What are all the inexact straight line mechanism is watt indicator, Thesbichev mechanism, and Stephan mechanism. So we can remember that. So indicator போட்டு turn பண்ண சைடில் போகணும். Like that. So if we put an indicator, we should turn like that side and we have to go, or else it will move on a inexact motion. Next is a rotary to sliding motion. For that, Scotch-Yoke mechanism is used. So and also Scotch-Yoke will give simple harmonic motion. In this simple harmonic motion, we have to understand the different positions, mean position and the extreme max position. So this thing we have to understand. The simple harmonic motion is applicable in piston cylinder arrangement when the piston is moved very slow motion, or else we can say it in a cam and follower mechanism when the cam and follower are rotating in a very small angular velocity or a very slow speed. We can call it as a simple harmonic motion. So simple harmonic motion is used in these kinds of areas wherever the moving parts are in the slow speed, where the simple harmonic motion is happens. And also in the quick return mechanism also there is a simple harmonic motion. If the shaper runs in a very slow speed, it is having a simple harmonic motion. For this consideration, the slider velocity of the dead center, which is inner is the mean position and outer is the extreme position for the shaping machine. In the shaping machine, mean position at the innermost point, displacement is 0 and velocity is maximum, acceleration is 0 and force is 0, kinetic energy is maximum, work done is 0, potential energy is 0 and power is 0. Whereas in the extreme position, displacement is maximum, velocity becomes 0, acceleration is maximum, kinematic energy is 0, force is maximum, work done is maximum, power is 0 and potential energy is maximum. This you have to understand. Next, likewise, the simple harmonic motion, in the cams having two different types of motion. One is a cycloidal motion. Cycloidal motion is available at the high speed and high velocity. When you consider when your two stroke or a two-wheeler engine, sorry for the two-stroke engine, for four-stroke engine, once a single cylinder four-stroke engine is running at a 10,000 rpm, what happen for the camshaft? Camshaft is supposed to be run at 5,000 rpm. On that 5,000 rpm, the cam and follower will operate at a high speed. The 5,000 rpm is a very high for the cam and follower. Therefore, on that particular rpm, it will like as a cycloidal motion, high speed, high velocity. Whereas in the cruising means we are in the vehicle, we are running it at constant and uniform acceleration, where that the cam and follower follows the parabolic motion. And simple harmonic motion, we know that slow speed or a moderate speeds, we are having a simple harmonic motion. Okay, so with this, I hope that you have understand the basics in the theory of machines. Next one is the inversions. Next we are going to discuss about the inversions, and that first the inversion of 4-bar chain. 4-bar chain will having all the 4 pairs are turning pairs. All the 4 are turning pairs. So here crank rocker mechanism is there. If we arrest adjacent to the crank, it is will produce the crank rocker mechanism. So crank rocker mechanism, the shortest link is fixed adjacent to the shortest link. So here you consider this is a shortest link and this is a longest link. So this is connected by means of a adjacent links. If the link adjacent to the shortest link is fixed, it will produce a crank rocker mechanism. So for the example, the beam engine is a crank rocker mechanism. And next one, it is a double crank mechanism. So shortest link is fixed. For the double crank mechanism, the shortest link is fixed. So this is the shortest link. When we fix this, what will happen? There is a relative motion over here, therefore it is move like this. For the better example, the coupling rod of a locomotive is the example of the double crank mechanism. Next one is the double rocker mechanism, or we can call it as a rocker mechanism. Here the link opposite to the shortest link is fixed. What is the link opposite to the shortest link? It is a largest link. When we fix the largest link, there is a relative motion for this link, and it will produce double rocker mechanism. Here, the interesting phenomena, the double rocker mechanism are used most of the mechanical application like anchorman steering, watt indicator, pantograph, all are double rocker mechanisms. And also the double rocker mechanism will not follow the will not follow the Kirchhoffian mechanism, whereas double slider uh, crank rocker or double crank mechanism will follow the Kirchhoffian mechanism. Next one is an inversion of single slider crank mechanism. In the single slider crank mechanism, one is sliding and three turning pairs are available. One sliding and three turning pairs are available. In all our IC engines are form under or follow under single slider crank mechanism. That is, when you will fix the one first link, if you link one is fixed, IC engine, reciprocating engine, frame is fixed. That is, frame is fixed. We have a mechanism like this. So this is the frame. If the frame is fixed, what will happen? The rotary motion is converted into here also a rotary motion, whereas this, sorry, one second. So this is a single slider crank mechanism. So this is the frame of the rotor, and this is the frame for the slider. If this frame is fixed, what will happen? The crank will rotate and the slider will move in this direction. Therefore, if the frame is fixed, it gives the IC engine or reciprocating pump. If the crank is fixed, with what quick return mechanism or radial engine is used. If the link 3 connecting rod is fixed, crank and slaughter lever mechanism is obtained or an oscillatory mechanism is obtained. Next, if the link 4 is fixed, that is slider is fixed, we can get hand pump or bull machine or pendulum pump is available. Next one, which is double slider crank mechanism. We already know that the famous Tamil film Osti is there for giving an inversion of double slider crank mechanism. If the first inversion is fixed, first inversion is the elliptical tormal, and second inversion is the Scotch yoke mechanism, and third inversion is the Oldham's coupling. In the Osti, you can go in the reverse direction for the inversions, for getting the inversions. And next one is an important mechanism, cross slider mechanism. Cross, from the name itself you can understand, cross or you make an R as a capital 1, R and S as a capital 1. That means wraps on slider is a cross slider mechanism. Next one is a offset slider crank mechanism. That is, the radius of crank, R is the radius of crank and E is the eccentricity. Slight offset of their connecting rod of length L is there. Therefore, connecting rod L is greater than or equal to R plus E. And next one, Kirchhoff's criteria for the 4-bar mechanism, that gives an equation like S plus L less than or equal to P plus Q. S is the shortest link, L is the largest link. P and Q are the links connecting the shorter and longest links. Non-Kirchhoffian mechanism is S plus L greater than or equal to P plus Q. This is called as a triple rocker mechanism. So there is some of the things are available in non-Grashofian mechanism. One is a Geneva mechanism, will produce intermittent motion, and a crank drag is the crank, drag the crank, and degree of freedom. A degree of freedom is less than 0. Degree of freedom is less than 0, or negative degree of freedom, it is called as a superstructure, whereas degree of freedom is equal to 0 and it is called as a structure. Next one is a constrained chain. For the constrained chain, there is a three type of constrained chain is there. One is constrained kinematic chain, and another one is an unconstrained kinematic chain, and third last one is a locked kinematic chain. These three chains are connected by means of a single equation that is called J is equal to 3 by 2 L minus 2. So this is nothing but your Kutzbach equation. This is done from the Kutzbach equation, derived from the Kutzbach equation. Therefore J is equal to 3 by 2 L minus 2. If the LHS is the J number of joints, where RHS is coupled with the constant of L, that is number of links. If LHS is equal to RHS, it is called as a constrained link kinematic chain. If J is less than or LHS is less than RHS, it is unconstrained chain. If LHS is greater than RHS, it is called as a locked chain. And I am going to add for your interest different mechanisms, three different mechanisms. One is a parallelogram mechanism, and another one is a deltoid mechanism, and another one is a compound mechanism. Here in the parallelogram mechanism, two links are equal and opposite to each other. So this is the interesting phenomena of parallelogram mechanism. Two links are equal and opposite to each other, whereas deltoid mechanism is the two links are equal and adjacent to each other. You can get a question like this: what are all the two link mechanisms? You can get a question. If there is a parallelogram or a deltoid mechanism, you are supposed to choose either parallelogram or deltoid mechanisms. Both are two link mechanism, so none other mechanism will give for the two links. Okay, so these two mechanisms will create two link mechanisms, and all the other are three or four links will have three or four links. Next is a compound mechanism. If a mechanism having more than four links, it is called as a compound mechanisms. I hope you have enjoyed the basics of theory of machines. So this is the overall introduction about theory of machines, both theory and dynamics of machinery. I hope you have enjoyed the session. If you have any doubts, please let me know in the comment section, and I will put another video for this. And thank you very much.